Hello, this is Ms. DB. In this video, we are going to look at some more theorems about circles, but this time we'll be focusing on the segments in a circle. So when two segments intersect, it might be chords intersecting or diameter in a chord intersecting, there's some theorems that you can find pieces of those chords, the measurements of. So here we have chord AB and chord CD, and they're intersecting at point E here. It turns out that the length from A to E times the length from E to B will be equal to the length from C to E times the length of E to D. So there's four different lengths there that you can be given. If you have three of them, or a way of finding three of them, you can plug them into this equation and find the missing one. So that's exactly what is happening in this first example. You're given three of them, you need to find the missing one. So do make sure that you plug them in correctly, that you write the equation correctly and plug them in correctly. So 6 times 4 will equal x times 8. And you put those into the equation, make sure you show that equation, show your work, and then solve for x. Once you find x, you're usually not done. Like this one says, find the value of x and the length of each chord. The chords are PR and ST. Well, we already know PR is 10, but you still need to write it. And then the length of ST is what you found for x plus the other part, which was 8. So in the next few examples, you're going to do, in these four problems, you're going to do exactly that. In each of them, you are given three lengths, and you just have to find the last one. Just double checking. Nope, none of them look too odd. Now, sometimes it's a little bit tricky to see what the number is referring to. Just assume that it's going towards the piece that makes the most sense. So in number 4, we're looking for y, which is PT. We are given that ST is 10 and that this must be TQ is also 10. And then we have a little segment over here that TR is 4. So that means that 4 times y will be equal to 10 times 10. Now don't forget that once you find what y is equal to by solving that, then you still need to go back and say that PR will be equal to whatever y is plus 4. And SQ, you can find that already by adding 10 plus 10 and getting 20. The next thing that we're going to learn about, first we have some vocabulary about what these theorems are saying. So first, a secant segment. A secant segment is when you have a segment of a secant with at least one endpoint on the circle. So a secant segment AE means that part of it from A to B is on the circle. B is on the circle, and then you have BE is the external part. So we'd call this the internal part and this the external part. An external secant segment, that's the part of that segment, that secant segment that lies outside the circle. And then a tangent segment, the whole thing is outside the circle. So we just call that a tangent segment. So these theorems will have to do with that information. All right, if you have two secants intersecting outside the circle, in the exterior of a circle, now be very careful with this theorem because it can be easy to do the wrong part. It's equal to the product of the lengths of one secant segment, that's the whole thing, times the external part, just the part on the outside of the circle, is equal to the whole secant segment, which is CE in this one, times the external part. You do not just multiply AB times BE equals CD times DE. You'll get the wrong answer. So you have to do the whole thing times the external is equal to the whole thing times, I didn't mark the external in this one, would just be from D to E. So be very careful of that. And the tangent one is going to be similar. So the whole times the external is equal to the whole times the external. So the whole of this one is 5 plus x. We don't know its exact amount. That times the external is equal to the whole, 4 plus 6, that one we know is 10, times the external. So you'll have to use the distributive property and then solve to find x. And then once you find x, it asks you to find the length of each secant segment, which is RQ and RT. RT we already know is 10. RQ you'll have to wait till you find x to answer. So the whole times the external equals the whole times the external. Whole times external equals whole times external. So let's look at, they're all looks pretty similar, like none are too tricky. Let's do number 8. Here's one of our secants, and here's one of our secants. So the whole of the blue secant is 18 plus 9, times the external part is just the 9, is equal to the whole of the red one would be n plus 12, and the external part is just the 12. So then we simplify, combine. 18 plus 9 is 27 times 9 will be equal to, on the other side, use the distributive property. So that'd be 12n plus 144. And then you just keep simplifying until you find what n is equal to. And that's how you'll do these problems. All right, oops, I went a little too far. The secant tangent product, this is really the same. It's going to be the same thing. You're going to take the whole times the external. Now, on the other one, you could do the same thing. You could say the whole times the external. It's just that it's the same thing. It's equal to the whole times the external. It's just that those will be the exact same number, so you could do just that length of that tangent squared. So if we just remember the theorem, whole times external equals whole times external, see in this one, the whole is 4 plus 5 is 9. The external is 4. In this one, in the other PQ, the whole is x, and the external is also x. So x times x is x squared. So I'm just going to stick with whole times external equals whole times external. Whole times external equals whole times external. It's just that sometimes that will be the same number. So let's look at number 12. So the whole in this one would be 5 plus 9 times the external part is just 5, and that's equal to the whole of the other segment, which is b, times the external part, which is also b. So that's the same as b squared. And then you will simplify the left side. 5 plus 9 is 14. So you'll take 14 times 5, and that will be equal to b squared. And 14 times 5 is 70. And then we'll have to take the square root of 70 to find the answer. Because if 70 equals b squared, we have to find b, so we take the square root to find what b is equal to. So the square root of 70 is 8.3666. And then they don't ask me to find anything else because b is really the tangent. It's the only other part we'd have to find. So in these ones, you just have to find what z is, what x is, what y is. And then the last questions are just a matching to make sure you know which formula goes with which of these pictures, and then an error analysis to explain which one of these made the mistake and what that mistake was. All right, make sure you show your work, write those equations, double check that you're solving these problems correctly, and have a wonderful day.